Remember that in geometry we use the word congruent much like we would use the word equals in algebra. So we would say that numbers are equal to each other, but we say that shapes or objects are congruent to each other if they're the same. And so congruent means that you have shapes that are exactly the same size and shape. So it's not enough for them to be like these two, where they look very similar in structure, but they're different sizes. These would not be congruent to each other, so none of these three are congruent to each other. But these three over here are congruent to each other. So even though they're turned different ways and they're in different locations, none of that matters. What does matter is that they're all three the same, have all the same sides, all the same angles. They are congruent to each other. They are the same. All right, if you have congruent figures, then we can start looking at corresponding parts. So that means the pieces of the triangles that are the same. So when we write a congruent statement, which would be saying that one triangle is congruent to another triangle, it's very important that we list the corresponding vertices in the same order. So the reason why we do this is because it tells you which pieces are congruent to which pieces. So a congruent statement is more than just saying that two shapes are the same. The congruent statement will tell you which pieces are the same as which pieces, as long as you write it correctly. So for example, if we want to say that these two triangles are congruent to each other, well, let's first just figure out which ones correspond to each other. Okay, so K, I'm going to put a box around that. Now K has one mark on its angle, and so does S. So that means that these two correspond to each other. So I'm going to put a box on both of them. Now L has two marks on it. I'm going to circle that one. And look at R here, it has two marks on it, so I'm going to circle that one. So L and R go together. And then J has three marks on it. I'm going to put a triangle around that. And T has three marks on it, so I'm going to put a triangle around that one. So those two go together. Another way you could look at this is that K is the angle between the side that's marked with one mark and two marks, and so is S. It's between the side marked with one mark and two marks. And you could go around and look at it that way as well. In any case, when we write our congruent statement, so say that I write the first triangle, this one here, as KLJ. Okay. And then I can say that's congruent to triangle, and then when I write the second one, I have to make sure to go in the same order. So I started with K, that's the one with the box around it, so that means I've got to start with S here, because that one has a box around it. Then I went to L, this circled one, so then I've got to go to R, the other circled one. And then finally J, the one with the triangle on it, that corresponds to T, the other one with the triangle on it, so then I write the one with T. And we could do this in any order as long as we're consistent with ourselves. So I wouldn't have to do KLJ and then SRT. I could do, say, LJK, but then I'd have to do the same thing over here, so I'd have to do RTS then. As long as both sides of the congruent statement are listed in the same order in terms of which corresponding pieces are which, then you're okay. So as long as you're consistent with yourself, it doesn't really matter what order you do it in. Now let's look at which ones are corresponding. So we already talked about this, but the two with boxes, so that's angle K, and angle S. Then also angle L and angle R, and then angle J and angle T. Those are the corresponding ones. So J and T were the triangles, R and L were the circles, and then K and S were the squares. For corresponding sides, well, if we look at, say, JK, so that's this one marked with 1. So segment JK corresponds with the other one that's marked with one segment, that's segment ST. So those two go together. Then we could say KL, segment KL. Okay, segment KL has two marks on it. Go over here, the one with two marks on it is SR. So that's segment KL and segment SR. And then finally we have segment JL, that's the one with three marks on it. The one with three marks on it over here is RT. So it's going to be segment JL and segment RT. Example 1. Write a congruent statement for the triangles and identify all pairs of corresponding parts. So let's again mark it the same way we did up here. So A has 1 mark. I'm going to put a box around that. So does F has 1 mark, so I'll put a box around that. B has 2 marks, so I'll do a circle around the ones with 2 marks, and then a triangle around the ones with 3 marks. Now, luckily enough for us, these are oriented in the same direction, so it's a bit easier to tell what's going on with this. So the congruent statement then, again, we've got several options. I'm just going to go around square, circle, triangle, so that's A, B, C. Then for the second one, again, I have to do square, circle, triangle, so that's F, E, D. So then the corresponding pieces, that'd be angle, or corresponding angles would be A and F. Then we'd also have angle B and angle E. And then we'd also have angle C and angle D. Those would be the corresponding angles. Corresponding sides then would be segment AB and segment FE. So that's AB has 1 mark, FE has 1 mark. Then we could say segment BC and segment ED. So both of these have, BC and ED, both of those have 3 marks. And then the last one we could say segment AC and segment FD. So segment AC has 2 marks, segment FD has 2 marks. So those all go together. All right, in the diagram, DEFG is congruent to SPQR. Now you'll notice that there are not triangle symbols before here or any kind of symbol there. So for any shape bigger than 3 sides, so this has 4 sides, and so does this one, we just write the letters. There's no special symbol that we really write for those. So just write the 4 letters for each, but the order still matters. So with this one, we started with D, so I'm going to mark these. I'll say do a circle for D, maybe a triangle for E, square for F, and then I'll underline G. So again, I started with D here, that's the circle. Started with S here, so I'll circle that one. So those two go together, D and S. Then the second one in each spot is E and P. So E I put a triangle on, so I'll put a triangle on P. Then F is the third one, Q is the third one here. So F I put a box on, so I'll put a box on Q here. And then G is the last one here, R is the last one here. So G was underlined, I'll underline R then. So I like doing this, kind of coding the picture like this, just because it helps you see a lot more easily which pieces go together and which ones are the same. Okay, so if we want to know the value of x, well, let's look for an x. Okay, there's an x right here, but there's also a y here, so that's not going to be helpful unless I've already found y. So then let's look for something that just has x. Well, here, this expression right here has only an x in it, 2x minus 4. Okay, so 2x minus 4 is the side that's between Q and R. That's the box and the underlined one. So then over on this picture, the side that's between the box and the underlined one is 12. So that means that these two pieces have to be the same as each other, because if these figures are congruent to each other, that means all the corresponding sides are the same and all the corresponding angles are the same. So this side is the same as this side 12. So I can say then that 2x minus 4 is equal to 12. And then we can solve this for x. So let's add 4 to both sides. And we get that 2x is equal to 16. Divide both sides by 2, and we get that x is equal to 8. To find y then, well, just like I looked at the beginning of this problem, we saw that this one had x and y in it. Well, now I know what x is, so I could plug that in. So I could say this is 8, so this is really 6y plus 8. And then I can use that to help me find y. All right, so this expression right here is in the angle with a square on it. So if I go over to this picture that has the angle with a square on it, that's 68 degrees. So that means that 6y plus x, which again x is 8, so I'm just going to substitute that in right away. That must be equal to this angle, which is 68. So then we can solve this by subtracting 8 from both sides. And we get that 6y is equal to 60. Divide both sides by 6, and we get that y is equal to 10. On the back side here, in example 3, we want to show that these two triangles are congruent to each other. So again, what it means for two shapes to be congruent to each other is that every corresponding side is the same as every other side on the other triangle, and every corresponding angle is the same as well. So we have to show that all three sides and all three angles are congruent to their corresponding pieces. So you can see here that these sides are marked congruent, and that these sides are marked congruent, and that these sides are marked congruent. So we've got all three sides. We just need to show that all three angles are congruent then. So if we look at, say, these two angles here, well, these two angles must be the same as each other. These are vertical angles, and we know that vertical angles are congruent. So I could say that angle PTS is congruent to angle QTR. Those two angles there are congruent to each other. So that's one set of angles. Now to get the other angles, we're going to have to use these triangles right here. And if you don't remember what these triangles mean, it means that these two lines are parallel to each other. And so if we look at, say, this line being parallel to this line, and then let's look at, say, this line right here. So what we have here are two parallel lines with a transversal cutting through them. Well, in Chapter 3, we learned some things about parallel lines with a transversal being cut through them. And one of the things we learned is that alternate interior angles are congruent. So if we have, again, two parallel lines with a transversal cutting through them, I can say that this angle is congruent to this angle. Those are alternate interior angles. So we can say that this angle is congruent to this angle because they are alternate interior angles. So that's angle SPT is congruent to angle, let's see, QRT. And we can do the exact same thing then for this angle and this angle. Those two angles must also be congruent because if you use this as your transversal, then you can see again that they are alternate interior angles. So I can say then that angle PST is congruent to angle, let's see, which one is it? RQT. So there's all the angles being congruent, and we were already given that all the sides were congruent. That was given to us on the picture. So we've got all corresponding sides congruent and all corresponding angles congruent. That tells you that these two are actually congruent to each other. All right, theorem 4.3, this is called the third angles theorem. And what this tells you is that if you have the fact that two corresponding angles in a triangle, in two separate triangles, are congruent to each other, then the third angles are also congruent. So let's use this with an example. I think, again, looking at actual numbers makes it kind of easiest to see. So let's say that this is a 100-degree angle, which would mean that this is also a 100-degree angle. And then let's say that this is maybe a 40-degree angle. So then this one would also be a 40-degree angle. So then if you know that this one's 100 and this one's 100, and that this one's 40 and this one's 40, then you would have to know that C and F, they have to be the same as each other. Because if you try to work out what C would have to be, well, all three of these angles have to add up to 180. So these two add up to 140, which means that this one would also have to be 40. These two add up to 140, take that away from 180, and you get 40 left over. And so that means that these two must be the same as each other. So then angle AD, if angle A and D are congruent, and if angle B and E are congruent, then it must be the case that angle C and F are congruent as well. Okay, let's look at example 4. Now we have two triangles here that are kind of mashed together. So one of them looks like this, and then the other one is this one right here, which I'm just going to redraw over here, just so we can keep the triangles separate from each other. So this is C, then D is over here, and then A is up here. So this angle here is 45 degrees, and then this angle down here is 30 degrees, and we're told that this angle, let's see, is congruent to this angle, and then also this angle is congruent to this angle, so this 45-degree angle is the same as this one. So then we want to know about this angle right here. So that's angle C. Well, again, we know that this one's 30. We know that these two up here are 45, so these two down here, this one's also got to be 30, because these two are marked congruent. So we've got 30 and then 45 at the top of these two. So then the third one, well, what we can do is, let's just call it x maybe. So we know that then x plus 45 plus 30 must be equal to 180. All three angles together must be 180. Combine like terms, that gives x plus 75 equals 180. Subtract 75 from both sides, we get that x is equal to 105 degrees. So this angle right here, this third angle, is 105 degrees, and that's going to be in both triangles. So angle C here is 105 degrees, but also this angle right here, 105 degrees as well. Now we're going to look at some properties of congruence. These are all things you've seen before. So the reflexive property, symmetric property, transitive property, there should be no surprises here. So reflexive property tells you that something is congruent to itself. So if we're looking at, say, triangle ABC, we could say that triangle ABC is congruent to triangle ABC. It's congruent to itself. So the reflexive property again tells us that something is the same as itself. Symmetric property tells us that we can switch a congruence statement around. So if I can say that triangle ABC is congruent to triangle DEF, that would be these two triangles here, then I could also switch that around. I could say that triangle DEF is congruent to triangle ABC. There's no difference between those two statements. That's what the symmetric property tells us. Then the transitive property, so that one tells us, so if ABC is congruent to triangle DEF, so that's these two are congruent to each other. And then if DEF, triangle DEF, is congruent to triangle JKL, then it must be the case that triangle ABC is congruent to triangle JKL. So we can make that statement exactly as is. So again, we're just kind of mushing together these two congruent statements. So we know that ABC is congruent to DEF, and then that DEF is congruent to JKL, so that means that these two ones on the outside must also be the same as each other.